Hello students, welcome to Gradeup, India's largest live learning platform. सही prep है तो live set है. Good evening all of you. Am I properly audible and visible to all of you? Please let me know once. Hi guys, am I audible? Just confirm once in the chat box. So in today's class, we are going to solve some previous year questions based on process synchronization, right? Just confirm once in the chat box, someone, if I'm audible properly and visible to all of you. So we are going to start. Okay, guys, do like the session, share with your friends, and also subscribe to Gradeup YouTube channel. Okay, so let's start. Before starting, let me introduce myself. My name is Anshul Sharma. I have 1+ years of teaching experience and mentoring GATE CS aspirants. In GATE 2020, I have secured All India rank 294. I have also qualified ISRO and NILET exam. My area of expertise is operating system, digital logic, DBMS, and compiler design. So those who want to prepare for GATE 2022 or 2023, so they can subscribe to Gradeup Super for Vision 2022 English batch, for Vision 2022 Hindi batch, or for Vision 2023 Hindi or English batch. Hi Raja, good evening. Good evening Navneet. Hi Vinod, good night. Okay, so for all these streams it is available, and you will be getting 850+ hours of live classes, 8000+ practice questions, 100+ mock test, and 120+ chapter wise study notes. For more information, you can even contact on this number as well. Hi Sudo, good evening. So Gradeup is providing flat 25% off on Gradeup Super subscription. So you can use this code TEACH25, and this offer is valid till today only on the eve of Teachers Day. So those who want to connect with me, they can join this Telegram group. This is the link, Anshul_Sharma_CS. You will be getting the PDF of all my YouTube classes, doubt clearances, and if you need any guidance, then also you are most welcome. So without waiting guys, let's start. This is the first question on your screen. So we have total 7 questions today, all from process synchronization, all are previous year questions. Yes guys, quickly solve this question number 1 and let me know what should be the answer here. This is not from 2021, this is from 2012, I think. Yes, everyone try to solve this question number 1, and let me know what should be the answer here. Hi Shubhadeep Mondal, pranam. Yes guys, do like the session and also share with your friends. Thank you Shubhadeep. Yes, Raja is saying option B should be the correct answer for question number 1. Yes, anyone else getting the answer? Very good, very good. Okay, let's see this question now. So consider Peterson's algorithm for mutual exclusion between two concurrent processes I and J. The program executed by process is shown below. For the program to guarantee mutual exclusion, the predicate P in the while loop should be. So here we have to find the value of this predicate P here. So in today's morning class at 11 AM, I have explained this Peterson's algorithm in a lot of detail, right? So those who have missed, they can, poll is not there, Vinod. In YouTube, poll is not there. You have to answer in the chat box. So those who have missed that theory session, you can watch that again on Gradeup app. Okay. So here, if we want to guarantee the mutual exclusion, then a process which is executing, it is going to check whether the other process is interested and whether the value of turn that is for other process or not. That means the process which has executed this turn statement first, we are going to allow that process first in the critical section. Okay, So if P1 is executing, so it is going to check whether P0 is interested and the turn of turn is equal to 0 or not. Okay, so that means option B will be the correct answer here, right? So it is going to check the turn as well as interest of the other process. Clear? Similarly, if yes, Raja, screen is blinking. Is it for everyone? Okay, so similarly, if P0 is going to execute, then it is also going to check whether the other process is interested and the turn is equal to J or not. Clear? So option B is the correct answer. Very good, all of you, those who have answered this question correctly. And for the theory, like how this Peterson algorithm satisfy all the conditions of mutual exclusion, progress, bounded weighting, and architectural neutrality, I have covered everything there today at 11 AM class. So you can rewatch that on Gradeup app. Okay, let's move on to the next question now. Okay, now is it fine, Raja? Please confirm once. And do solve this question number 2, that is based on producer consumer problem. And let me know what should be the answer for this second question. Yes, everyone try to solve this question number 2. If you know how this producer consumer problem works, what is the classical problem and how we resolve it, so then definitely you can answer this question easily. You should know how it works. So read it properly and then try to answer this. And guys, do like the session, share with your friends and juniors, those who are preparing for GATE exams, so that they can get the benefit of these classes. Okay. Yes, what should be the answer for this question number 2? Anyone getting the answer? Should we solve it now? Or do you need some more time? Okay, Raja is saying option A should be the correct answer here. Let's solve this question now. Consider the following solution to the producer-consumer synchronization problem. The shared buffer size is n. So we have a buffer, the size of buffer is n. 3 semaphores, empty, full and mutex are defined with respective initial values of 0 and 1. So we have one empty semaphore, that is again a counting semaphore, right? And the value of empty semaphore is 0 initially. The value of full is n, and the value of mutex, that is a binary semaphore, the value is 1. Clear? Semaphore empty denotes the number of available slots in the buffer. Okay, that means if empty, initial value of empty is 0, that means there is no slots available in the buffer for the consumer to read from. That means everything is empty, the whole buffer is empty. Thank you, Shubhadeep. Thank you for your compliments. Okay, so if empty is equal to 0, that means there is nothing for the consumer to read from the buffer. Okay, that means producer hasn't produced anything. Now, semaphore full denotes the number of available slots in the buffer for the producer to write to. So as you can see, full is equal to n. That means you have the complete buffer for the producer, so that producer can produce an item and it can store it in the buffer. Now, The placeholder variables denoted by P, Q, R and S in the code below can be assigned either empty or full. Fine. The valid semaphore operations are wait and signal. Which one of the following assignments to P, Q, R, S will yield the correct solution here? Right. Now carefully see. As you can see, initially there is nothing to read from the buffer for the consumer. That means we want first producer to execute its code. Is it clear so far? We want first producer to execute its code. If I want producer to execute its code and I don't want consumer to execute first, then definitely weight of R will be, if I say R is equal to full, then in that case consumer can execute its code first, but I don't want that. So that's why R should be equal to your empty here. R should be equal to your empty here, because I don't want consumer to execute first. Now if I'm taking R is equal to empty, as you can see empty is equal to 0, so the process, consumer process will get blocked here. Clear? It is going to get blocked here at this statement. Clear? Yes, exactly. Now I want producer to produce something, so definitely this P has to be full. The P has to be full, so that if producers produce an item, it is going to make this as n minus 1 because it is performing wait operation, and then wait of mutex, so it will make it 0, right, and add item to buffer, right. Then signal of mutex, make it 1 again, and signal of q. Now as I have produced one item, now I may want the consumer to consume that item, right. So that is why this q has to be what? Empty, so that I can signal this empty semaphore and I will make it 1, so that now if I have one item already in the buffer, now consumer can consume that. So we are signaling empty, right. Similarly this S has to be full, because after consuming the item, now it is again going to make this full. It is going to increment the value of full, so that producer can again write an item, add an item. Clear? So this is going to be the placeholders here. So for P it is full, for Q it is empty, for R it is empty, and for S it is full. So option C is the correct answer here. Yes, Raja, yes, option C is the correct answer. Maybe you have committed some silly mistake. Okay. So what they have done here is they have changed the the meaning of empty and full here. If you compare with this original producer consumer problem, there you have it different. So always read the question properly and then try to answer that. Okay. Let's solve this question number 3. Yes, is it fine now? I think there's some issue in the internet connectivity. Is it fine now, Raja? Okay, thank you. Okay, yes, everyone, try to solve this question number 3 now and let me know what should be the answer here. So all the questions that I have taken are from this previous year. Okay, Raja is saying option A should be the correct answer. I think again it is buffering. Okay, let's solve this question now. The following program consists of 3 concurrent processes and 3 binary semaphores here. Okay, the semaphores are initialized also. S0 is equal to 1, so S0 is equal to 1, S1 is equal to 0, and S2 is equal to 0. Now how many times will process P0 print 0? Clear? How many times process P0 is going to print 0? So as you can see the code of P0, you have this while loop. That means you can execute P0 many number of times, or you can say the number of times you want to execute this P0, you can do it. But process P1 and P2 are going to execute only once, because there is no while loop here. Okay, there is no while loop here, so we are going to execute P1 and P2 only once. But P0 you can execute infinite amount of times. Clear? Now let's see. Suppose we can we start with process P1? No, we cannot start with process P1. Why? Because the value of S1 is 0. So if you perform wait of S1, it is going to get blocked. Similarly, you cannot start with process P2 as well, because S2 is equal to 0. If you are going to perform wait operation, it is going to get blocked. So that means we have to start first with P0. Clear? If we start with P0, so while of true, that is fine. Wait of S0. So let's make it 0. Wait operation we are performing, we are going to decrement it, right? Then print 0. So let me write the output here. So we are going to get print 0. We are going to print 0. Then release S1. So as we release S1, we are going to make it 1 now, right? Now, suppose I perform another operation as well, release S2. So we can have multiple cases. We can have preemption also. Okay. So here, suppose we are not performing, we are not doing preemption. We are completely executing P0. We will take preemption case as well. So release of S2, let's make it 1. Now, suppose I want to execute this process P1. So wait of S1. So if I do wait of S1, it is going to make it 0. And now release of S0. So it is going to make it 1. Now before executing P2, I can even execute P0 now. If again I execute P0, so what it is going to happen? So I have executed P1 one time, right? So wait of S0, so it is going to make it 0, and then again it is going to print 0. That means at least 2 times, or you can say 2 times we are printing. We will be checking whether we can print 3 times or not, right? Yes. Now here release S1, let's make it 1 again, but we cannot execute P1 again because there is no while loop here. You can execute P1 and P2 only once, but still we can execute P2 because we haven't executed any time now. So wait of S2, it is going to make it 0, right? And then release of S0, again it is going to make it 1, and then again wait of S0 you are going to perform and print 0. So 3 times also you are printing, right? How 2 times you can print? Let's take that case as well. S0 is equal to 1, S1 is equal to 0, S2 is equal to 0. So start with P0, wait of S0, fine. Here it is the output. So you have seen 3 times we are printing. Now we are going to check whether we can print 2 times or not. So here S0 is equal to 0, fine. So first time you are going to print it, release S1, make it 1, and then release S2, make it 1. Clear? Now execute P1, wait of S1, make it 0, and now what we are going to do, release S0, so make it 1. Now before executing P0 again, let's execute P2 again. Okay, P2. So S2, wait of S2, make it 0, and now release of S0. So already S0 is 1. Even if you are performing signal operation, you are going to get 1 only. That means both P1 and P2 have executed one time. Now it's over. Now you can execute process P0 again. If you are going to execute process P0 again, wait of S0, make it 0, and print 0. So 2 times you are going to print. Even if you release S1, make it 1, make it 1, but as they cannot execute more than once, P1 and P2 cannot execute more than once, so you are going to get twice. Clear? So in this case, when you are executing first P0, then P1, then P2, and then P0, then you are getting 2 times. If you execute P0, P1, again P0, then P2, then P0, then you are getting 3 times. So at least 2 times you will be getting according to the options. Clear? Option A is the correct answer here. Yes, very good. Yes, Raja, your answer is absolutely correct. Let's solve this next question, question number 4. All of you try to solve this and let me know what should be the answer here. So you have to analyze cases, okay? Yes guys, do like the session. If you find these sessions helpful, then do like it and also share with your friends. If you want to get the PDF of this class, you can join my Telegram group. The link is Anshul_Sharma_CS. I will be sharing the link as well after completing all the questions. Okay, so you can join it. There you will be getting the PDF of this class if you want to refer it. You can also ask your doubts there in this group. Okay, and if you need any guidance related to your preparation, then also you are most welcome. Yes, everyone solved this question number 4. Let me know what should be the answer here. Yes, am I audible, guys? Yes. Sorry. I got disconnected. Maybe there's some internet connectivity issue today. Am I audible now? Please confirm once, all of you in the chat box. Okay, let's solve this question now. Question number 4. Okay, thank you Raja. So suppose if we want to synchronize two concurrent processes P and Q using binary semaphores S and T, the code for the process P and Q is shown below. Synchronization statements can be inserted only at points W, X, Y and Z. Which of the following will always lead to an output string this? So we want to arrange this W, X, Y and Z in such a way that we are going to get always this output, right? So we have two processes P and Q and these are the codes. Now if I want this output always, then you can clearly see P is printing 0, 0, Q is printing 1, 1. That means always I want first P to execute and then Q, then P, then Q. So strict alternation will be there, right? And also the execution should start from process P only, right? If I want that, then see which of the option will give us the correct answer. So if we consider option A here, so P of S at W. So if I take P of S at W and V of S at X, right? And here it is P of T at Y, P of T at Y and V of T at Z. Now S and T initially it is 1, right? Now carefully see here, as you can see the value of T is 1 and here I am performing wait of T, then that means I can even start with Q, right? But we don't want that. That means option A cannot be your answer. Clear? So in this way you have to analyze each and every option and you have to eliminate it. Let's consider option B now. So here S is 1 and T is 0. Let's make it 0. And here P of S, this is V of T now. This is V of T now. And this is P of T and this is V of S now. Okay. Now S is 1, T is 0. Definitely you cannot start the execution with Q and we want that only, right? We want process P to start first. S is equal to 1. So if we start with process P, wait of S. So let's perform wait of S. We are going to make it 0. Clear? Yes. We are going to make it 0. Now print 0, 0. So we are going to print 0, 0. This is the output. Clear? Even if you preempt in between, still you cannot execute Q until you signal T, until you make the value of T as 1. And you can only make the value of T as 1 through this V of T operation. Clear? So when you perform V of T, you are going to make it 1 and then process Q will be able to execute. Even if you want process P to execute again, you cannot do so because already it is 0. Clear? So that means strict alternation we have maintained and we are starting the execution with process P only. So yes, now process Q can execute and it is going to print 1, 1. It is going to make this 0. This is going to print 1, 1 and V of S. So it is going to signal the value of S. Now P can execute. So strict alternation will be maintained. Like this, we are going to get the output. Clear? Option B is the correct answer. You can analyze option C and D also, but they are not going to give you the correct answer. Option B is the correct one. Very good, all of you, those who have answered this question correctly. Yes, now let's solve the next question. Question number 5. Yes, so that is a connected question. Just the difference lies here. Just the difference lies here. Okay. Yes, everyone try to solve this and let me know what should be the answer for this question number 5. And guys, do like the session, share with your friends. Everyone try to solve this. Okay, Raja is saying option C should be the correct answer for this question number 5. Okay, anyone else getting the answer? You can answer in the chat box. So let's see this question now. Suppose we want to synchronize two concurrent processes P and Q using binary semaphores S and T. Again the same question. The code for process P and Q is shown below. So WXYZ you have to find out. Which of the following will ensure that the output string never contains a substring of the form this and this where n is odd? That means you should not get this kind of string 010 or 0110 or 0111 You should not get this. Apart from this, also you should not get this 101 1001 100001 like this. Okay, where n is odd. Clear? So we should not get this. So how to eliminate the options? Let's see. Let's consider option A first. P of S at W. Let's do it. P of S at W. V of S at X. So V of S at X. P of T at Y. P of T at Y and V of T at Z. Clear? Now both S and T, both it is initialized to 1. Both are initialized to 1. Now carefully see. If I suppose I start the execution with process P here, so it is going to perform the wait operation. It is going to decrement the value, make it 0 and print a 0. Let me write it the output here, print a 0. Suppose if I preempt the process P here, and if I try to execute process Q, it will be able to execute. It is going to make it 0, right? And it is going to print 1. Again if I preempt, and again if I print 0 here, that means I'm getting this kind of string which I never want. So that's why option A cannot be our answer. Similar case we are going to have in this option B as well, because both are initialized to 1. Clear? So what I want basically is, first complete process P should execute or complete process Q should execute. There should be, if there is a preemption, then also other process should not be able to execute. That I want here. So definitely option B also you can eliminate in similar way. If you consider option C here, so P of S here, V of S here, this is also P of S and this is also V of S. That means you are using only one semaphore and the value of that semaphore is 1. Now if you start with P, you can do it, make it 0, print 0. Even if you preempt the process and try to execute Q, you cannot do it because this is P of 0 and already the value of S is 0. That means you have to continue with the execution of P only. So you will be printing 0 0 and then you are going to perform V of S. Then you can again execute P or process Q here. Exactly, very good. So we want the process should be atomic. We don't want any preemption here. So if we don't want any preemption, so we are arranging these semaphores in such a way so that we can have that kind of thing here. Okay, so that processes will be able to complete execution without any preemption. So either you are going to get this kind of string, or this is also possible, right? And yeah, that's it. Or you can have this also. Again, you can execute the same process as well. So these kind of strings are possible, and in these strings you are not getting these kind of things, right? So option C is the correct answer. Similarly, you can avoid option D as well. Option C is the correct answer here. Again, the same thing is happening. Just a minute, guys. I think there's some technical issue. I have to resolve this issue. Yes, I'm sorry. Okay, let's solve this question now. Question number 6. So today many things are going wrong in this YouTube class. First, my internet connection, and now this technical error. Yes, everyone, try to solve this question. Question number 6. This is the second last question of today's class. Yes, quickly solve this and let me know what should be the answer here. So this is a numerical answer type question, and you can solve this question within 1 minute. Even in 30 seconds also you can solve this question. Yes, very good. That is the correct answer. Let's see this. So consider a non-negative counting semaphore S. The operation P of S decrements S and V of S increments S. During an execution, 20 P operations and 12 V operations are issued in some order. The largest initial value of S for which at least one P of S operation will remain blocked, or you can say at least one process will remain blocked. So here, if I'm assuming S is my initial value, 20 P operation, that means 20 times I'm going to decrement it, 12 V operations, so 12 times I'm going to increment it, and finally one process should remain blocked, at least one process, so we can make -1. The final resultant value should be equal to -1 because negative value of counting semaphore indicates that one process is there. If it is -1, that means one process is still blocked. Now if you solve this, this is -8 is equal to -7, and finally you will be getting S is equal to 7. So that is the correct answer. Yes, very good, all of you, those who have answered this question correctly. Now solve this last question of today's class, question number 7, and then we are going to wrap up this class. Yes, all of you, quickly solve this question. Anyone getting the answer? So here you have to find out what is the largest number of processes that can be inside in the critical section at any moment. Okay, Raja is saying option D. So let's say this, each process Pi, that is from 1 to 9, is coded as follows, right? That means from process P1 till P9 you are going to have this code. The code for P10 is identical except it uses V mutex in place of P mutex. That means here you are going to have view mutex, and this is for P10 process. Now here, suppose you first execute P1 process. So P of mutex, let's take mutex value as 1 initially. So P of mutex, you are going to make it 0. Then P1 is present here in the critical section. Now if P2 comes again, it is going to get blocked here because mutex value is 0. But for P10 it is view mutex. So P10 can again execute this. P10 can execute this code infinitely, and it is going to perform view of mutex. It is going to make it 1. P10 will come in the critical section and then it can exit also. Then P2 will be able to allow it, right? If P2 again performs this P of mutex, it is going to make it 0. P2 will access. Similarly, P3 will also come and all the process P9. Then again P10 also comes in this critical sections. That means at a time you can have all the 10 processes, and if you have even more processes, then also you can have this. Clear? Due to this P10 process, as it is incrementing the value of mutex again and again, so other process can access the critical section also. So that's why option A, B, C all are incorrect. Option D is the correct answer, and 10 is the correct answer basically here. So here option D, that is none. Clear? Yes, very good Raja, that is correct. Clear? So we have covered all the questions here, and if you want to get the PDF of this class, you can join this Telegram group Anshul_Sharma_CS. You will be getting the PDF, doubt clearances, and if you need any guidance, then also you are most welcome. This is the mega mock challenge schedule for this September month, so you can attempt all these tests and you can perform well, right? And these are the star faculties we have at Gradeup for computer science courses. All are highly professional and experienced. In GATE 2021 we had 10 plus gradients under AR10 among all the streams. So if you want to prepare in a well structured manner, you can do so, right? You will be getting unlimited access to structured live courses by India's best faculty, complete doubt resolution, full syllabus coverage for your exam, 100 plus online mock test designed by the toppers based on the latest exam pattern. For more information, you can even contact on this number as well. Yes, Raja, tomorrow we don't have class at 11 a.m. As I have some work, I have to go to the office. So due to that, we have cancelled that class. Okay. Right. So you can also install Gradeup app and you can attend all the free classes and attempt mock test. So thank you all of you for joining these class, and I will see you very soon in the next class. Till then, take care and bye-bye. Good night, everyone. Yeah, good night. Bye-bye.